data, big data, big data. So what exactly is big data? If I see the terminology big data, the thing which I see more into this is the data. Data, it places a prominent role in the complete real-time scenarios. If I check, let's say, let me take a very simple example for you. Let's say you are in an office and you have various IoTs and you have various infrastructure over there. So the moment you enter a door, you are entering into a door, right? You are opening the door. If I collect the inputs from the particular door, let's say I'm opening a door. So what force I'm applying to the door to open it, and what is the friction which is applied at the hinges, and what angle I'm taking this, like until what angle I'm moving this thing. So this is what I'm be collecting the data. This is the data which is collected in some structured way. Like I have some metrics where I can define it for that. Let's say, let me go in a little more deeper, understanding the data. So we seen the structured data, like if we can define a terminology for that, we define it as a structured data. Let's say, as I said, when the moment we are applying a force on a door, we are trying to open it. So with the amount of like the data we collected, we have a metric to store that. So it's a structured data. Let's say I have a Facebook. I hope everyone is having a Facebook account. So let's just assume, like, what is Facebook like exactly? What is share option? Do they have any data type for that? Or do they have any metrics to store the data? Well, obviously there is no data type for that. So, but still we need to store the data. Like if I want to know, like, how I'm generating a value for that, like, how many number of likes did you get for your pic or your display pic. This is what exactly I'm making analysis. So this is where I am collecting. So how I am collecting the data? This is a data which is generated in an unstructured format, where it doesn't have a structured way defined for it to store the data in a database. If we compare with the earlier databases like RDBMS, Oracle, MySQL, SQL Server, so these are the IBM DB2. So there are different databases which stores the structured way of information. So in simple terms, let me say what exactly the data is. So data is being classified into three different types. One is structured data, and unstructured data, and semi-structured data. Right? It's very clear, right? So we have seen the example for structured data. We have seen the example for unstructured data. The semi-structured data. So semi-structured data, if I go to a network log, basically logs are our best friends. So if I go to the log, I see the information with respect to the application and with respect to the middleware application. Both the applications will be, so it will be a combination of structured way and unstructured way, which is, we term it as a semi-structured, right? So this is what how exactly the data has been evolved into. So let me define the state of data. If I see what the data is, so data, like, from the last 6 years, I see the amount of data which has been generating is tremendously and exponentially growing on. So it's like, if I consider a social networking site like Facebook and LinkedIn, they generate more than 1 TB of data per hour. Imagine how many hard disks should be required for a day. Imagine how much the amount of storage do we require for a week. Similar way, calculate for a period of 10 years. So you'll understand how exactly the data is being generating from the uh, social networking. Similar to that, there are various categories like manufacturing industries, hospital, pharmacy, everything is generating a huge amount of data. Even let's consider a simple example. I hope everyone has traveled in flight, right? So when the flight starts boarding from its origin, it generates almost 1 TB of data. Some of the things, if I go into little more deeper, what is petroleum level, what is the engine speed at which it is moving, and what is the speed at which it is traveling, what is the propellant uh, dimensions, and all this. If I consider all these things into action, it generates more than 1 TB of data. So let me move forward. So we have seen what the different types of data. So we understand what exactly the data is. So how do you term that as big data? So till now we understand what exactly the data is. So we seen the coming to the last 6 years, we see there is a tremendous growth in the data. So how do you term the data as a big data? Right. Moving forward, like what is big data and why big data? When we call the data as a big data, and how can we define the data is termed as a big data? This is what exactly our problem is. So the problem is very simple. So if I consider, there are three different ways. I can simply say the characteristics of big data. So if I consider three different ways: volume, variety, and velocity. Let's say for a particular category, let's say for Facebook, earlier, before 6 years, the amount of data which is generated is in terms of gigabytes and terabytes. Now the amount of data which has been generating is completely of more than terabytes to petabytes of information, right? This is what the volume exactly. And similar to that, the type of variety of data. So the amount of the type of data which is generating is structured, semi-structured, and unstructured. And even there is few more log information also comes on the unstructured data. So all the varieties of data will be storing. Similar to that, the rate, what is velocity? Velocity is the rate at which the data transfers from one specific, like one source to a specific destination. Is called velocity. In simple terms, like let me explain you with one example. If I consider a little years back, we do have a floppy disk where it stores of 3.4 MB of data. And the writing speed is 512 bytes per second. This is how the writing would be. If I consider right now, I should get a 1 TB memory card, uh, which is having a speed around almost 130 Mbps or 40 Mbps per second. Imagine how much the data traveling, like how fast the data has been traveling. This is what exactly the velocity is. In simple terms, like when can we turn the data as a big data is by considering the three different ways, the characteristics of the big data, we can term the data is known as a big data, right? Moving forward, let's just understand the difference between like why we came with this concept big data Hadoop. So we understand the problem, we understand what exactly data is, and we understand what is the problem. So problem is the big data. So what is the solution exactly? So we came with a solution called Hadoop, where it has a processing capability as well as storage capability. So when coming to the previous years, I have a problem in storing the data and I'm not able to process the data. So my data is at rest. So what I'm doing is I'm making my data to be in motion. So what I'm doing is I'm providing a layer where I can store the data as well as I can process the data. This is where exactly the Hadoop came into existence. So Hadoop started in 2006. So if I see, let's just get into differences between a traditional RDBMS and the Hadoop. So in traditional RDBMS, we do have a specific hardware required. Let's say if I want to install a Oracle, I need to have a specific hardware which is running of particular number of cores and particular amount of RAM sufficient for the application to run, the middleware application to run properly. Whereas coming to Hadoop, I can run it on a commodity hardware, where commodity is cheap hardware. Either I can run it on a normal local machine, and it's a open source. Whereas traditional RDBMS like Oracle, it's a paid software. Like it's specifically designed for a specific use, and the data model, the structures of the data, all the stores in a tabular format, whereas in Hadoop it stores in a even Hadoop has the different file formats. Still we can store whatever type of data is, either it can be structured, semi-structured, and unstructured of data. So when coming to traditional RDBMS, it's quite expensive and difficult if you want to scale it to a large number of clusters. Whereas Hadoop, it's very simple and it will be very scalable and it can be scaled up to n number of nodes. It depends upon application. This comes under the cluster planning and resource management. This is the topic where you will understand the scalability option for the Hadoop, like how to scale this Hadoop, how to plan a cluster, what is the things we need to take into consideration and set the things up for a particular specific application. And as seen, so these guys, like traditional ADBMS, have a proprietary OS and database and network. Everything has their own, whereas the Hadoop, it's open source and it can run on a commodity hardware, and the basic networking is sufficient to move ahead with the Hadoop distributed file system, right? So I'm just moving ahead. So as I already discussed all these points where Hadoop is scalable and it can be helps us in processing the various types of data, the structured, unstructured, and semi-structured. Like these are the couple of examples, like for unstructured data, images and videos, and semi-structured like Apache logs, search logs, and network logs, and router logs, anything. So coming to NoSQL, so NoSQL, in simple terms, we can call it a not only SQL. That means it doesn't mean that it doesn't have SQL. It has SQL. The functionality works as similar to SQL. So, and it has a very good tolerant architecture wherein it can scale horizontally with the addition of the servers. And couple of examples what I discussed, Facebook, and here I have given one more example, Twitter post, where this is one quite example where it generates huge amount of data which is unstructured format. So various use cases, like you can say various categories where we use the big data, like the problem big data is still there, and we are using Hadoop as a framework to solve this problem. So in social networking, I gave you example like Facebook. Coming to banking sectors, yes, there are banks which are implementing Hadoop for storing the data. Let me give you one simple example. For banking, let me go to a banker and let me ask for a statement for a period of couple of months. Let's say it last 2 months. So how much time will it take? It just takes 5 minutes to get the information. Let's say I ask the manager to get the statement for a period of 20 years, for the last 20 years, for the time I open the bank account. So is it possible to get the information right away? Well, hopefully it is not possible as of now. So banking sectors are implementing in such a way where they can get the information then and there. So basically the information stores in the rack server. We'll get into more details how the infrastructure is. So before we start with the setting up the things. So coming to education sector, like many education institutes like BITS Pilani, Triple IT Hyderabad, IITs are using the big data, and they have different projects like data analysis, data mining on top of using the big data architecture. Coming to transportation, many transportation comes into different things. Either it can be a air, or it can be a bus, or it can be a train, rail. Everything, everyone is using the concept of big data where they can solve the problem. They're using the Hadoop to solve the problem big data. Coming to gaming industry, Electronic Arts, one of the best gaming company, which uses, earlier they used to use mainframes. Like I hope people come from gaming industry, they usually use the mainframes to make use their application to run on the servers, like their games and all these things. Basically nowadays they're using Hadoop to make like the game running in little more faster pace. Manufacturing industries, retail market, and pharmacy, one best example is Walmart. Coming to pharmacy, right? So various companies, these are the various companies which, if I go with Hortonworks, these are the distributions still. Yeah, these are the company which uses the big data Hadoop as a underlying platform and develop their own product upon that. So Cloudera is one thing, Hortonworks is one thing, Apache Hadoop is IBM Big Insights, Mapper is one more big data distribution, and Vertica, which is developed by Hewlett Packard, Greenplum, which is from EMC Square, and from Teradata it's Azure Data, and IBM has one more tool called Netza, which helps in processing the big data thing. Similarly, Microsoft has a Windows Azure, which is the upcoming platform which works on both three components like infrastructure as a service, application as a service, and software as a service. So they developed the complete Hadoop platform in such a way one can run with like in fraction of seconds. The moment you want a specific instance to run it, just click a button, you'll get the things up and running, right? So if I go into little more understanding, like what can I do? Let me interrelate this concept with the traditional RDBMS. If I have a database, so basically what I do, I need a database, like I have a database. In that I create a database and I create a table and I create like data inside it. Like either it can be of rows and columns. Similar to that, I do a query on that. I do a insert on that. I do some advanced analytics on that, and I use it like a file system, like storing my entire data, and I use for visualization purpose, like I use ClickTool or Pentau